My name is Dave Caro. I'm a developer advocate here at BlazeMeter, and another term you might have heard of be like technology evangelist. My job is to sort of pay attention to our more advanced customers, learn what they're doing, and sort of share those trends with others. And along those lines, I'm going to be sharing today what we're seeing in terms of what we call a shift left in democratization of performance testing. It's really about how you go beyond a centralized use of legacy load testing platform like LoadRunner or Sole Performer, etc., or Performance Center, to a shifted left democratized usage where you're using open source tools and how that can help you achieve greater test coverage without slowing down your release cycles. We're seeing a lot of these changes happening in the context of Agile and DevOps. When people are coming to us and saying, my current tooling doesn't really make that transition. What are my options? And so we want to share some tips about how you can have your own successful transition on that journey. Here's the agenda I'll cover. My first point is that the legacy tools created the Center of Excellence really as a bottleneck. And the Center of Excellence is a place with some very talented people and some very big investments. By its definition, how it was created and how the tools work, it led to sort of a natural bottleneck. Now we'll take a second and refresh Agile and DevOps, where one of the key goals is to eliminate handoffs and bottlenecks. Obviously, if you have a bottleneck and you're adopting a new methodology that's about not having bottlenecks, you clearly have a problem, right? So that's sort of what raised this whole conversation in the industry. The third thing we'll do is we'll look at why open source tools have emerged as the go-to way to solve this problem. In the fourth section, we'll talk about what I call the Center of Excellence 2.0. Now, I'm not suggesting the Center of Excellence is a bad thing or that it needs to be eliminated. Far from it. Actually, it just needs to be flipped. The Center of Excellence can move from being a minder of a queue and a performer of work to the provider of a framework where lots of people can do work for themselves. This is the democratization we're talking about. Shifting left is really about doing the work earlier in the process, or at least starting the work earlier in the process, right? You may still have a certification later in the process, but more work sooner is how you get more coverage. The benefits of shifting left and having testing happening sooner, these are really obvious. You find problems more quickly, you resolve them before they're expensive, and so the question is, how can the Center of Excellence transform itself, flip itself inside out to become a Center of Enablement, the provider of this framework? Then we'll talk about how to get started without reinventing the wheel. And with the DevOps and Agile environments and these movements, it's very common for people to take a shot at building their own tool set to put things together. One of the cool things about a lot of these tools is that they're inherently building blocks, right? They're things that can be kind of assembled and built into a tool chain. We'll talk about experiences we've had with people who've gone that route and how you can get started without having to reinvent the wheel. And then lastly, I'll share a case study from one of our customers that had some very big goals about shifting left, and they pulled it off, and they learned a few lessons along the way, and they were very generous to share them with us so that I could share them with you. So let's jump right in. So my first point is that legacy tools created the Center of Excellence bottleneck. And legacy tools, most notably LoadRunner Performance Center, were for years, they've held the largest market share. They did a lot of really amazing stuff, primarily in sort of the client-server era, and then again Y2K. These tools were something you could depend on for shaking out client-server apps, for beating the daylights out of systems proactively in the laboratory environment. And the thing is, these tools had some aspects of them that got us the bottlenecks we face. Let's take a look at kind of how that happened. The first thing is that they were complex, right? There's a lot of complexity. They're complex to set up and complex to use. And because of that, you inherently needed specialists. Makes sense. You needed highly trained specialists, and that factors into what happens. Second, restrictive licensing. Sure, it was expensive, but much more than that, it was restrictive, even at the physical level, where controller licenses are node-locked to a single piece of hardware. If you didn't know, a controller literally has a license that's node-locked to one physical box, right? And if you wanted to use that controller for more than one project, you literally have to put that controller on a dolly and wheel it down to another lab in order to be able to do both kinds of tests, to test both environments. And that's pretty restrictive. And what that meant is that you had to solve that problem in terms of how you design your performance testing infrastructure, and that meant you needed a Center of Excellence, which was both a place and a team. And between the complexity and the restricted licensing, it made sense to have the centralized function. And you had some very highly trained people and some major investments, including the licenses that were fairly scarce. And you needed some center where it could live, right? And that was great in order to reliably have someone you could go to when you said, hey, I've got a performance issue, or I think I might, or I want to figure out if I do. Can you please, set me up? And the challenge is that by its structure, it meant you had to hand off from the team that was doing the coding to the team that was going to do this testing. And even in the best of cultures, that kind of that kind of environment creates friction in the handoff, right? So, and this is what you end up with a small number of practitioners and a scarcity of infrastructure. Naturally, there was a queue. And the larger the organization, really the larger the queue, which is kind of ironic because it had larger investments and larger budgets for this stuff. We've seen firms with very large budgets that had a 60-day queue for performance testing, which is, you basically have to ask for a window 2 months ahead of time. And, you wouldn't want to walk into a store and see that your number was 982 and they were now serving, number 27. And it's no fun to have curiosity about whether your code performs or not, or to try to meet a delivery milestone and be told you got to wait 2 months for a chance to test it, right? So performance testing kind of became synonymous with really big investments, expensive resources, long lead times, and to these newly forming agile teams that wanted feedback early and often, unacceptable bottlenecks, right? So that really leads us to this review I'll do really quick on. So let's talk a little bit about, I think most of the people on the line are probably aware, they probably have some pretty strong goals about kind of going towards DevOps or an agile environment. But let's just take a quick minute to kind of review a couple key points about why centralized resources just don't really make sense in an agile and DevOps environment. So core principles. I'm taking these from the DevOps Handbook by Gene Kim, Jez Humble, Patrick Dubois, and John Willis. This is really kind of a bit of a Bible. It's kind of thick, but literally the first 40 pages are where all the gold bits are in terms of understanding the mindset and what it takes to pull this off. And I'm going to share the 3 core principles that are introduced in that first 40 pages, and they are here. The first one is flow, which is that you want to be in a situation where stuff moves through quickly. It doesn't spend very much time in one place. You do this by having small batch sizes and eliminating constraints on the team, right? Your goal is to get stuff out either further through the pipeline or all the way out to the real world as quickly as possible, sort of early and often. And the reason you want to get that out to the world fast is this second point, feedback. The key here is to be able to get feedback quickly, both from end users by getting stuff all the way out to your customers, or if you're talking about earlier in the development cycle, feedback about errors or performance issues. And then there's this notion of swarming defects. In the old world, we would have sort of a development cycle, and then we would hand it off to QA, and then developers sort of lay idle for a bit while the QA people get up to speed and understand all the stuff and read the specs and start setting up their environments. And then as soon as they get everything set up, they start to find bugs, and you build up a bug backlog, and then there's a burn down, right? These terms we've heard over and over again, burn down. So a burn down shows how quickly we're melting through the new bugs and how, in spite of finding new ones while we're doing more testing, and there's sort of this mindset that we've got this big pile of stuff that we're going to chew away at. In this new world, when you're talking about swarming defects, the idea is that you, instead of having a big backlog of bugs, the moment you find anything wrong, boom, you swarm on it and you squash it. So we've actually run into environments where they have a rule, which is that there can never be more than 1 open bug per developer on a sprint. And that may sound crazy to those of you who can think of hundreds of bugs in a burn down, but think about it. That's an environment with the smaller batch sizes and the fast feedback where your code is always ready to go, right? And you don't end up with 6 months of work and 3 months of backlog chewing away at bugs. You have a team that's always building small incremental changes, and they're cranking stuff out when they find a problem, and they fix it quickly. So you also want to get feedback from customers quickly. So the last thing is continuous experimentation. You want an environment where it's safe to play with stuff, to move things around, to change things, and to see what happens. When you learn something, and the goal here is to actually be able to experiment and change things because you're not constantly working on a big 6 or 9 month monolithic blob of project. And when you learn something, remember, Agile and DevOps kind of spreads the work out into smaller teams. The goal is to make local discoveries, but then have a culture of sharing those with the other teams, right? So the authors sum up kind of the reason for all this and what it accomplishes really well, which is the goal here is to deliver business intent fast without heroics. We've all worked on projects where we get, there's always that period in the project where you call home and you say, hey, I'm not coming home for dinner, and I think I might have to work this weekend because it's crunch time, right? You're doing the heroics to try to make the deadline or to solve some problem before some launch or something. And the idea here is to have, through having more of a flow and more of the small batch sizes, is that you have a well-oiled machine and you have continuous testing in place. You don't actually have as much heroics. You just kind of do your thing and get through it, and there's much less drama, right? So let's talk about how flow is achieved in Agile. And this is actually, it's really pretty simple if you look at it. There's 2 things. One, is small teams working in parallel, many small teams. So if you're a big company and you don't aim to have a giant organization working on one feature, you break it up into feature teams, right? And they merge their work as they go. Having many small teams working in parallel, these teams are designed to be self-contained to avoid friction of handoff, right? And that's really the other point, which is the teams are self-contained to avoid handoffs and constraints, right? You want to have them work autonomously so they can do whatever they need to do without waiting on anybody else. And less friction means more time spent with flow. And this is kind of self-evident when you look at it, but obviously it's a transition from the old way of doing to the new way of doing, right? So shifting gears a bit, why did open source performance testing take off as the Agile and DevOps movements did? And again, this is actually, when we step back and look at it, it's pretty straightforward, which is, why did it emerge as the tool of choice? Well, frankly, because it was a self-service, pain-driven, zero-friction model. If you wanted to do some testing, you just downloaded the tools and started using them. You didn't have to ask for them. You didn't have to open a purchase requisition. You didn't have to have a vendor evaluation. You just literally went and grabbed these tools, downloaded them, and started using them right in your work group, right? And you could learn on YouTube. You could see examples. You could spin stuff up using your own machines or the public cloud. And there's a huge open market of shared knowledge and plugins and design patterns that you could draw on, really at your own pace and based on your own needs, right? And if you think about it, if performance engineering has been synonymous with the Center of Excellence and the very large investments in people and licenses, then going to your boss or your boss's boss to go out and buy something else that would meet your newer needs was probably going to be, again, a friction thing, something you really want to deal with. And they didn't have to. They could just go get the open source tools and start using them. They're effectively working around the Center of Excellence by doing this, right? And democratization is really the natural remedy of the bottleneck. People spread to the edge to get the work done they needed to do. And so that was sort of the good news. The thing about this is that it was free like a puppy. And by free like a puppy, if somebody gives you a puppy and doesn't charge you anything, that's great, but you're still going to have to pay for vet bills, and you're still going to have to find a place for it to sleep. Maybe you're going to get a dog bed, or you're going to have a kennel. The dog might end up chewing up your furniture. So there's really no such thing as a free puppy, but free like a puppy, open source was indeed free to get started. But there were some things that didn't come for free with the open source as these teams at the edge were adopting this, right? There were gaps, and frankly, there were some fairly significant gaps. How do you tell JMeter to go leap up onto the cloud and bring up 100 machines and run a test and consolidate all the results? You have to figure that out with a lot of scripting and a lot of your own cobbling together, right? How do you get reporting in real time? It takes a lot of clever cobbling to figure that out. It used to be that it was impossible. Now you can sort of do a lot of again, a lot of heavy lifting, and you can piece it together, right? JMeter doesn't do that out of the box. Collaboration. How do you share the results easily? You'd have to build some sort of repository that you somehow move the results into and then you somehow publish, right? Again, possibly not rocket science, but a lot of effort to just be able to share the results, right? Test management. How do you watch the tests over time? How do you compare test over test? How do you make sure you can get back to the previous results from the previous build? Then support. So, you can Google to get answers to most of your questions, which is awesome. But how do you learn, new tricks? Maybe the stuff's on Google, maybe it's not, or you're on a tight schedule, or you're trying to do something that you can't seem to find a lot of support for in the real world. Where do you go for support? So these are things that are missing in open source, right? And these gaps have actually created an opportunity for a new role for the Center of Excellence and for all people who basically whose job it is to enable development teams to be productive, right? Which is, where do people go when they need these tools? They go to the Center of Excellence, or they go to a centralized tools organization. In this new world, those organizations can be the one that makes these gaps go away by actually being a facilitator of democratized testing, right? So that leads us really to the core of where the action is. What's actually happening right now in the more scaled up kind of commercial environments, right? So I call this COE 2.0, facilitating shift left and democratization. Another way to look at this is transforming the COE from a Center of Excellence to the Center of Enablement, right? And I'm just going to share 3 attributes that are in common with the transformations we've observed, the ones that have succeeded in shifting testing to the left earlier in the development cycle and democratizing access so the performance feedback is quick and accessible, which lays a foundation really for continuous performance testing and a massive rise in test coverage. So the first one is self-service, which is that self-service is everything. You want to get out of the business of managing a queue of work and instead hand out logins, API keys, and automation interfaces and let the teams run and do what they do on their own, right? And I group self-service into 2 key areas. make it easy to get started, and make it easy to automate and integrate, right? Before we imagine what that really looks like, and do I have to have a framework, or how does this work? This is a bunch of libraries. There's really just two simple things you need to address. One is you need a web UI for fast onboarding. People need to be able to go to an address and get everything they need to get started. They need someplace to be able to go to ad hoc testing when they haven't yet automated. You want to automate things, but before you do, you just need to do stuff. And the web interface, a web interface that people can get to easily, just does that. It's a good way to share reporting and to collaborate. It's we have these tools like Slack or GitHub, these web-based things that developers are used to using, where they kind of come together and share stuff, right? The other thing you need, owing to this whole shift left and the desire to automate and have developers be at the center of this, is open APIs and command line interfaces, CLIs, right, for fast automation. Integration without needing a plugin. Plugins are great, and a Jenkins plugin is cool. It sort of does one thing, sort of finite things that have already been thought out, right? The example in the performance testing space would be, I've got a test that I've built, it's somewhere on a server already, I just want to wake up that server and tell it to run the test. And if the test already exists somewhere else, yeah, that helps. But if, for instance, you say to yourself, I've seen a check-in of 4 modules of code, and I want to find the right test for each of those 4 modules, and I want to assemble them into a single unit of test, and I want to launch that test right now, plugin isn't generally going to help you do that kind of control. You need more flexibility, and that's why open APIs and command line interfaces are awesome. And again, you want to unleash the small autonomous teams and get out of their way. So that's point one, self-service, right? The second concept, and this is one which, again, I'm kind of amazed that people don't really think about this one until we talk about it, and then it sort of seems self-evident, right? Which is that it's sort of a no-brainer, which is to parallelize everything. When you parallelize everything, an entire test only takes as long as the single longest component, right? Typically, you have a bunch of tests and you run them sequentially. That's how we've been doing it forever. You know, the nightly builds and then the series of sequential tests run against them, right? And people would line up a whole bunch of tests and they're going to run through this suite, and that means you have this long-running test window. And if you could compress those test cycles down to minutes by running things in parallel, you end up in a situation that's considerably more scalable. You can grow your test coverage without lengthening the test cycle, right? So if you're trying to increase your maturity, you're trying to increase from, say, 50% test coverage to 70% test coverage or whatever, the last thing you want to do is have it take longer to get feedback, which is that essential past part of the process. You want fast feedback, right? So by going in parallel and running your tests at the same time, you eliminate that. And, really it all nets down to this, which is the best queue is a queue with just one test in it. And by that I mean at the very moment you decide that a test should be run, it should just start running. It should just start happening. You don't queue it up to run tonight. You don't queue it up to run the next time you get a testing window. This is a development environment, and you want to be able to get feedback. You want to commit code, get up to go refill your water bottle, and by the time you get back to your desk, you want to know whether everything's okay, right? It needs to be that fast, right? So the best queue is a queue with one test in it, and as soon as it's in the queue, it's actually executing. No person has to actually do anything at this point. It just happens. So the third point is that you want to provide an execution platform that amplifies rather than constrains the use of these open source tools, right? It gets back to those gaps, right? If you can fill them, you get open source community innovation and enterprise class support, right? You want to get scalability of reporting and collaboration and integration, but you don't want to make somebody who Googled it, went out and found an open source tool, built some tests that they've been running these locally. You don't want to make that person redo them and change them and move stuff around and refactor their stuff to fit into the framework, right? You want to tell them, okay, I just need you to refactor a few things. If you could move this over here or convert this into that, then it'll work on my platform that I got for you. That sort of blows the whole idea of enabling these people to self-serve and getting out of their way. So you want to let them get things done, and you want to get the benefit of the innovation without putting any barriers in the way, right? And I don't mean to beat a dead horse, but you don't really want open source based. You don't want, it sort of uses open source or I can import things. You want to actually be able to just use it, which leads to my next point, which is about getting started without reinventing the wheel. If you get this new reality and you get the notion that by shifting left, you can do 10 or even 100 times more testing than you could ever do in a centralized world, then these are the things you need to be able to pull off, right? So as you embrace this new reality, you face a decision. Should I dedicate resource to build my own pipeline of tools that will enable these open source tools to be sort of more group-oriented and more enterprise-friendly, or do I focus on putting work through the pipeline itself, right? And that you face that with really all your tools, right? Which is a balancing act. Do I want to build just what I need, or do I want to focus on building the stuff that I'm supposed to be shipping? And at BlazeMeter, we have a mix, right? We have two kinds of customers that come to us. One is a customer who comes to us because they already know they don't want to build their own. They have a vision for what they want to accomplish, and they just want to start using it. The other kind of customer is somebody who comes to us because they have built their own. We all learn a lot from each other when these people come to us, because they come to us because they found that it was kind of hard, and it takes a while. They've created a minimally viable product. It needs maintenance, and they realize, you know, if the person who built this leaves, we're in really big trouble. And frankly, I'm now having to justify a budget for people to maintain this tool set, and I've got 2 or 3 headcount going here, and this is kind of getting a little out of control. So we get both kinds of customers, but obviously we'd recommend that instead of building your own and then coming to us later, that you consider coming to us, or at least evaluating us in the process, right? So, and here's why you don't really need to reinvent the wheel. With BlazeMeter, we've already built a platform that facilitates self-service, lets you run tests in parallel, and amplifies open source tools. We talk about democratizing performance testing in the continuous delivery era. And there's really 2 parts to that. First, democratizing performance testing, and that really just means giving more people access to it, right? Spreading it around, giving everybody the ability to run their own performance tests, right? And in the continuous delivery era, that speaks to this decentralized thing, this fast flow, this time frames where people need to be able to do things without sort of making an appointment for a month or 2 from now, right? And supporting wider adoption beyond the previous way we did these things. So let's talk a little bit more about BlazeMeter. It's a SaaS and on-premise performance testing platform designed to help DevOps and Agile teams begin their web, mobile, and microservices and API testing earlier in the life cycle, right? And then be able to reuse these tests all the way through to and really beyond production. So a little bit more. So first of all, it's pure SaaS, which means you just need a browser to get started. You just need a browser to be able to collaborate. Geography doesn't matter. Licensing doesn't matter. Anybody can get a login, and you just get in there and start using it, right? We take open source, 100% open source compatibility really seriously. We call this load and go, which is that if you've got JMeter or Selenium or Gatling or Grinder, Siege, Sung, if you've got any of these tests already built, you just literally drop them into the platform and they'll run. You don't have to reconfigure them at all, right? And then we have the ability to run from over 30 geographic locations and or behind the firewall and in a private cloud, right? So we provide the flexibility to create this load, whether it be very small load for early stuff or rather very, very large load for testing even your actual production or pre-production infrastructure, right? And so it's massively scalable. The same technology that can run on a developer's desktop can actually be scaled up to run over 2 million virtual users. And the whole goal here is to boost productivity and get you towards continuous integration testing. And frankly, you notice it says continuous integration testing and not just performance. The platform can be used to do automated API functional testing. It's quite powerful what you can do once you've actually are enabling people to use these tools in a more structured way. And we bring comprehensive reporting, right? So out of the box, the open source tools have some kinds of reporting, but typically people have to repurpose the stuff, have to download the data to their own repository, create their own dashboards, etc. We have comprehensive reporting that's easily shared, that's easily collaborated around, right? And then finally, integration with APM tools, with CI/CD frameworks, and a REST-based API that underlies it all. And the reason why I point out the REST-based API is that, like more modern applications, we build the sort of the microservices and the APIs first, and then we wrap a web interface around it. So even though we're a SaaS-based web app, is how you would see us in the demo, underneath that is published APIs that our own team uses to interact and that our customers use to create customized interactions with our platform. So one way to kind of sum this all up, we're taking open source technology and helping you have an enterprise-grade way to run it, right? Enterprise features and integrations, reporting and scalability, security, reporting, transparency to be able to know who's doing what and how things are going, and then support, right? Commercial support that's actually on the hook to make sure you're successful, right? And you'll see, a number of the open source platforms underneath: Locust, Gatling, JMeter, Selenium, and the Taurus framework, which is an automation framework. We can talk about more in a bit. And I'm actually going to take it up even one level higher, just to kind of net this out. This is a graph of interest in the keyword DevOps on Google over time, right? And starting with that very flat line way back there in 2008, there were some ripples of early conversations, but really in 2010, 2011, this started to take off. And this is where BlazeMeter was founded. So BlazeMeter was created in the DevOps movement. We've only ever existed in a DevOps world, right? So we were born with this movement and we grew with it, and importantly, this is the only way we've actually ever really seen what we're out to do. We've had a clear vision of democratization of speed and automation from the very beginning. And in the marketplace, everybody really has to have a story right now about Agile or DevOps or shift left, but we have it in our DNA, right? And that's really, I think, one of the reasons why CA chose to acquire BlazeMeter was that we already had this figured out, and this is actually absolutely where people are trying to go. And we care about this democratization of performance engineering to our core, and take contributing it to its success and to yours really seriously. So the last thing I want to share is, and I'm able to share this because I had a customer who very generously shared it with me, which is a case study before and after shifting left, right? If we take a look at this, the arrows at the top are their feature releases, right? Their development sprints, if you will. So that green one is a feature release, and at the first code complete line, they had finished the work on that green release. And partway through that release, they began doing some functional testing. SQE here is software quality engineering, right? Started doing some functional testing manually while the development was being done, but they continued testing that green release all the way through, manually, all the way through to the point where even the next release had been finished. And at the very end of that functional testing work that was being done for the green release, they started to do some performance testing. And then only after that did they start developing their automated functional tests. Right? In the meantime, along comes the orange release, and it hasn't yet been tested because they're still kind of wrapping up the testing for the green release, and then comes the purple release, right? And so they're always a little bit behind, right? And this is kind of the world we've all been living in for a while, which is that automation was something you tried to get around to, and hopefully you got a bit of it done, but invariably the next release came along, and so you had, and the automation would break, and so you'd sort of focus a lot on manual testing, right? And so there was always this technical debt and this temptation to kind of drop things and move to the next release. And the manual testing they were doing wasn't systematically repeatable because, this manual testing. And the performance testing was really only partial, and it was only happening after they thought they were done. And so they would find problems way too late in the process, which would cause really disruptive context switching for the developers. I mean, obviously, if you've shipped a piece of code and then 6 weeks later somebody raises a bug and says you've got a performance issue in your code that you finished 6 weeks ago, then it's really frustrating. You have to literally refresh not just physically what's on the desktop, but what's in your brain about what you were doing, right? So very costly. And so they decided they were going to commit to doing this, which is they were going to shift all their testing to the left, which is that for each feature sprint, they were going to perform every kind of test before they considered that feature release done. And that's integration test, features test, regression, security, performance, all that stuff. And the performance testing was done as part of every feature release. That way they were getting immediate feedback to the team, and that testing was happening right from the very beginning. And I love the fourth bullet, tight collaboration between dev and software quality engineering. And the reality is here is it's less about collaboration and more about being embedded, which is that you can't have two silos that meet more often. You have to have the people who are doing quality live on the same team as the people who are doing development. And all the automation was done as part of the initial testing. So they tested stuff using automation, and that way they're able to do regression testing on every code update. And every kind of test with build-breaking criteria, not just sort of a high-level smoke test or a quick manual test, right? So that was their goal, and they had a pretty strong deadline to get there. And here's a little bit about the scale of this. So they had 20 separate application teams. Each of these teams was doing about 10 pull requests a day. So that meant they wanted to be able to run 200 performance test runs in a day. And if you're used to sort of the typical, scheduling a window on a test apparatus, obviously this would be a nightmare. 200 performance test runs a day. You're not going to spawn, you're not going to have, 50 or 100 test labs. No one would do that, right? So they had to be able to run 4,000 test runs in a month, and here's how they went about it on the first pass, which is, and by the way, this organization has a Center of Excellence, has LoadRunner, but for this project, for this shift left testing, they didn't even, they knew that they just couldn't go there with that, right? And so where they went was they went to this open source solution. They had a Jenkins server, a Jenkins master in the middle, and it was calling out to 20 Jenkins slaves. Each Jenkins slave had JMeter on it, and it would run the tests as code was pushed through. Now, this kind of looks like parallel, but in reality, this is one slave per project team, and these project teams had about 10 pull requests a day. So invariably, this meant things were still queuing, right? So someone might wait quite a while for their code commit to actually get through the pipeline and end up with results, right? And then when they ended up with the results, they had reports in 20 different places. And the reports were in, kind of the simple format that JMeter spits out. And they had some high-level dashboarding in Jenkins, which sort of pass-fail and the like, but they couldn't get very much detail. So these are the things that they were wrestling with, which was that this approach was inefficient and a little bit painful. It was single-threaded, as I mentioned. Each team was still queuing up behind these. They had issues with instances where an instance would fall over or need to be upgraded, so they're spending a lot of time care and feeding on these instances, and of course the pipeline would stop when an instance would go down. The results were unorganized. They were sort of all over the place. There was no easy way to do trending and to have high-level statistics or even to be able to go from high level to drill down. And there were just, frankly, too many headaches and too much manual care and feeding. So they came to us and said, we like some of what we've accomplished here, but we don't like the headaches, the care and feeding. We're spending way too much time on the infrastructure, and it's distracting us from our main goal. So this is what they switched to. Was they kept that Jenkins master, and they just pointed the Jenkins master to a BlazeMeter infrastructure, and BlazeMeter handled all the tests for them and put all the reports in one place that everybody could get to, right? And this is what they cited as the things they liked about transitioning onto the BlazeMeter platform. It was multi-threaded, so things could actually happen in parallel. They got dynamic instances, so we're creating fresh instances for them all the time. We're keeping them up to date. They don't have to worry about maintaining and upgrading the instances. The results were very organized. They're very shareable, right? And it was very easy to do trending comparisons. And finally, they got monitoring plugins, which they actually hadn't taken advantage of when they were just kind of going at their own. So that they could get their APM data in showing what's happening in the back end overlaid on their performance testing results, right? So that's the end of the case study that I wanted to share with you. So hopefully we've talked a bit about kind of what's happening, what people are doing. This is one company that has actually gone through this process and gotten to this state. And now I'd like to shift gears and kind of make this a little more real for you by handing off to my colleague, Sid, who will give you a live demo of BlazeMeter.
So just a short introduction of who I am. So my name is Sid. I also came through the CA acquisition of BlazeMeter. I'm a solution architect here with BlazeMeter, so I can definitely cover more of the technical aspects, understand what the product does, talk about integrations, showcase some of those as well. But what I'll be doing today, as David mentioned, he talked about the solution itself. I'll show the solution, so we'll talk about where BlazeMeter comes in, what you can do with BlazeMeter, specifically how does the reporting look like, where do we set up integrations, so that there's a good understanding of where and what you can do with BlazeMeter itself. The initial part of BlazeMeter, as David mentioned, we are purely SaaS-based, so you log into the application, and there's an easy-to-use UI that you can interface with. Right, so anything that you want to do in terms of performance testing, in terms of functional API testing, BlazeMeter can support that through the web UI itself. So I've logged into my environment. As you can see, there's a list of tests that I've executed. There are updated tests that are showcased here within the platform as well. And that's the great thing about BlazeMeter, right? Because it is a platform. One of the things of running a performance test is data warehousing, right? Keeping that data and making sense out of that data as well. If you just use a tool itself, for example, if you just use JMeter itself, it stores the data locally on your laptop, and then what happens is when you run another performance test, it becomes very difficult to actually collaborate and compare those results because, again, they're stored locally. There's no real data warehouse that can keep that data for you. So that's where the platform comes in. That's where BlazeMeter comes in, where you can see all the types of tests that you might have saved within the platform. Again, we keep that data for you, so you have access to it at any given time. The same thing goes for reports. If you actually execute these tests, they now become reports. They are actually performance tests with performance data that you can dig deeper in, understand the relationship within the KPIs, and understand exactly where the bottlenecks might have occurred. So that's the first part of BlazeMeter. It is that platform that keeps the data. The second part is collaboration, right? So we understand that there's not going to be just one member using the product, running all the performance tests in the organization. Again, that's not democratizing it. That's also not shifting left as well, right? So there's going to be multiple members. There's going to be multiple members that need to run performance tests. And within the BlazeMeter platform, it's as simple as inviting them with an email address, right? So you add their email address. They now have access to, we call them a workspace. So you can actually see it sitting there in its workspace. This is my private workspace that I'm working on locally, not locally, but within the platform. And if I want to invite members to this workspace, I would just add their email addresses to that workspace. So there's an enterprise-grade platform feel where you can have more and more testers, you can have more and more users within the platform, and there's no restriction based on the restriction licensing. You have access to the platform. You can run the performance test at any given time. So let's go ahead and create a performance test. So the ability to create a performance test is done through the UI. There's a list of options that we have here. So there's things like a JMeter test, which will take a script, which will take data files, and you'll be able to execute those scripts. What we also offer is a multi-test. So if you have more and more scripts that are more microservices oriented, you want to run them as a combination, you can run that multi-test, which will run these multiple scripts at the same time. The same thing goes for a distributed performance test. Maybe you'd like to run a cloud test that is all around the world. You can set that up within the multi-test and get a very realistic performance test going forward. There's a couple of other options as well. We'll cover that today. Taurus, which is our CLI automation framework. So that supports actually multiple languages and tool sets. So if you have Selenium, Gatling Grinder, we can actually use those scripts, reuse those scripts, and run a performance test against them. The last thing that I'd like to cover is our test creation tools. So we actually offer multiple ways of creating script. You can definitely write them initially in open source if you need to. If you need to write a script in JMeter, we can fully support that script. But again, there are other ways of recording these scripts so that at least you have a baseline to work with. We have what we call is a recorder. It's a proxy recorder, and you can point your browser to that proxy, and it will record every single request and create a JMeter script out of it. What we also offer, and this is something that is brand new to our product, is actually an API test maker. So what we can do is actually create a Swagger file. This will allow you to run a functional API test with us and actually increase that test coverage, right? So not only can we do the performance testing, we'll also help you with the functional API testing as well. So I'll go through the JMeter test. So within the JMeter test, we'll go ahead and I'll just name the performance test. There's also the ability here to upload the relevant scripts. So the scripts themselves are just the actual JMeter script that hold the endpoints, that hold the scenario. We can go ahead and upload those relevant scripts. And if you're using data files, you would upload the relevant data files here as well. Right? So anything that's related to the script, upload it within the container. From there, it's just setting up the load configuration. Right? So I'll breeze through this, but basically, as David mentioned, we do have the ability to test from cloud locations. We have actually it's more than 30 now. We have actually about 35, 40 locations that we can run the performance test from, and we can test internal applications as well. So if you'd like, we can install a private load generator behind your firewall. If you have endpoints that aren't publicly facing, that load generator can target those internal applications and send the results out to BlazeMeter as well. So in terms of the locations, you can see that AWS has tons of locations, Google has tons of locations, there's Azure as well. So you can run a distributed setup. If you need to run a private test, you can go ahead and do that as well through the private location selection. So the UI experience does not change. Whatever your use case might be, you can select the specific location and the type of application that you're testing as well. So I'll select a location for now. I'll select 100 users. So these are all spun up through the UI. We can actually dynamically spin up more and more users through the platform itself. That is the ability that BlazeMeter gives you, is It's a more dynamic load field. You have a use case that's 100. Next week it changes to 1,000. You just change the number and you can run the performance test. Okay, in terms of configuration, so we understand in the DevOps community there are other tools that you might be using, right? So we do integrate with a lot of these tools. We integrate with APM tools, we integrate with CI tools, and most of the integrations you can set up within the configuration screen. So if you'd like, you can set up the APM integration within the test config, and that would allow you to see what's happening on the server side and also what's happening on the APM side of things as well, and correlate that information. So you can set up these integrations here with these products depending on what you're using, and that's done through the test configuration. A couple of other things just before we get into the reporting. So there are, when you're getting to the point of automation, right, there's not going to be true automation right from day one. You'd want to run those unit tests, run the ad hoc tests, and then you get to the point of integrating this with your CI and CD pipelines, and then you get into true automation. Right, so the first step that we see is a customer, there's always an SLA that an application might have or the organization might have. For an example, the response time of any services should never be beyond 3 seconds. Right, let's say that's an example. What we can do on the performance side is we can set that up as a failure criteria. So if the response time does get beyond, let's say we actually set it up to about 3 seconds, so the response time can never go beyond 3 seconds, right? And if it does, this performance test will fail in BlazeMeter. If you set this up and integrated this with any of your CI and CD pipelines, this will also control that process as well, right? So in Jenkins, let's say for an example, if you add this part of your build steps, this will actually fail the build if this failure criteria has been met or exceeded. So it's a quick and easy way for you to start automating these performance tests, setting up these criteria so that you can control what's happening if things go wrong, and if things don't go wrong, what exactly you have in terms of the reporting as well. So that's the ability to save and create a performance test. Obviously, this is more on the JMeter side, so we do support other open source tools as well. Just to show you how easy it is to spin up a performance test. So this will just give you a confirmation screen saying you're going to launch a performance test, and I'm okay with it, so I'll launch the servers, and this will take about 30 seconds to about a minute for the reporting to come back. Okay, so just because we are a little bit less on time, I'll go to a test that I've already ran, and this will give you the reporting after the test has ran, obviously. The great thing about BlazeMeter reporting is the test results come in real time. So right when the servers launch up, which takes about, again, 30 seconds to about a minute, you will know exactly what's happening right when the performance test started. Okay, so if there starts to be a bottleneck, if response times start to increase, you now have the ability to see that exactly when that happens and understand what needs to change or stop the performance test or tweak some parameters so that you have the ability to understand if things will change during the performance test as well. This is the reporting, so you're seeing the summarization, right? Obviously, when you run a performance test, you're looking for key KPIs, you're looking for virtual users, you're looking for my throughput, right? How much activity did the script generate, how many errors did I receive as well, and how did the response time look like? Right, so right from the get-go within the BlazeMeter reporting, we give you all these relevant KPIs, we give you some high-level reports as well. We do one notch better, actually. We give you a whole report system that you can basically select different KPIs and correlate these KPIs against each other. Right, so if you're looking for a specific trend, and the trend that I always look at is while my users are going up, how are the response times reacting? Right, and you can actually plot that out where I have my virtual users. I also have my response time checkbox selected, and when the users are going up for this specific use case, you can see up until about 260 users, the response time is about 3.8 seconds, and it does not go beyond that up until we get to about 370 users. We go from 3 to 4 seconds to 5 to 6 seconds. Right, so there are some bottlenecks within that zone. We can go ahead and plot out more information here. Maybe you like to plot out when you had more errors during the performance test. And that same trend applies when the users are going up. When we get to that 4 to 6 second increase, the errors go up during the performance test as well. So great way to visually understand what's happening. We do provide a table format report as well, so you can actually see exactly by the request what types of KPIs and what the values of those KPIs are. And we have the ability to see exactly what's happening during that performance test. So there are tons of reporting data. We give you the visualization. We give you error reporting as well, so you know exactly what the errors are and when they occurred, what time they occurred during the performance test. In terms of the platform collaboration, there are multiple ways of downloading data, sharing the data, comparing the data. So if you like, what we can actually do is we can, let's say I had this performance test has a 5-second response time. I definitely want all members of my team to know exactly what happened in the performance test. Instead of me downloading the whole data or taking screenshots, what we can do is we can quickly click on the share button, and then there's a shareable link that has been generated. And within the shareable link, basically it's an access to the report, so you can see the timeline report, you can see the table format report, and you don't need to be logged into a BlazeMeter profile to see this information. Right? So even if there's an outside vendor or a third party that you're working with and send them that data, they can still access this information and understand what happened during the performance test as well. The last thing is summarization. So, and I see this often where a customer might run a 24-hour performance test. After 24 hours, there has been other work because, again, during those 24 hours, you're not actively on the performance test. So there's always a big need to summarize that information, and some of that summarization gets difficult because time has passed. What we can do is we have a one-click executive summary, which will take the results and give you a full and executive summary that will summarize the data for you. It will tell you what were the important KPI, those metrics. There will be, it will categorize the types of errors that were happening during the performance test. It will tell you how long the test was for as well, and then there's reports on here as well. Okay, so you can get to the point of using our web UI. Right? So this is only the web UI demo. There's also the command line interface that we can work with, how you can automate it, how you can automate this through Jenkins and run your performance tests. But to start out, BlazeMeter is the web UI, and then there's all types of integrations and types of performance use cases that we can offer as well. So just to summarize, it's a web UI, fully SaaS-based. You can take your open source scripts, and then you can add a great level of execution. You can also add integrations with other products, and the main focus of any performance test is reporting. So we can offer the real-time reports. You can correlate that information. Once that's done, you now have the ability to use BlazeMeter as a data warehouse and also collaborate on these reports as well. Any questions on the product, any questions on understanding the strategy of performance testing, that's definitely something that we can address as well.
One question that someone asked early on, which is that, how do I get access to the BlazeMeter solution? Anybody can go to blazemeter.com and click Start Testing Now to get a free account. But BlazeMeter is a wide open platform that allows free forever low-scale accounts. So let's go to the next question. How do you pull in test data for script integration, right? So typically you're going to use a CSV file or series of CSV files to bring the data in. If that data is static, you could just have that be stored as part of your test configuration. If that data is going to be changing, then you would probably want to use more of an integration approach where you would use the Taurus tool to call the data as part of your pre-test activity, add the data to the configuration, and then launch the test. If you're generating a test with a test data management tool, you'd make a call, either API or CLI, to them, get the data, and add it into the test. But streamlined, automated way to do that would be to use the scripting, and my recommendation would be to take a look at Taurus and its pre-test actions capabilities as a way to do that. So another question, follow-up question to the test data. If yes, what formats does Blaze support? So BlazeMeter, remember, is a test execution framework for multiple open source tools. The one that the vast majority of our users use is JMeter. JMeter out of the box supports CSV files as the primary format you would use to get the data in. There are other options, but that's the sort of falling off a log obvious easy one. I recommend a person who asked this question, if you want to go a little deeper, the short answer is definitely CSV files, but the way BlazeMeter is designed is that any asset that your test needs, if you were setting it up in the online web portal, you literally just drag that asset into the window where you're creating a test, and all those assets will be made available where the test is executed. So if it's a plugin, if it's a data file, if you have a way where you're interacting with a file that's not a CSV file because you've written some plugin or something that does it, just has to be in that same folder or a subfolder under it, and you're good to go. I want to thank everybody for spending their time. I know everybody's really busy. Hopefully this opens some frontiers for you. Most of us are being asked to accomplish a shift to the left and to do things faster. That doesn't really mean just multiplying what we used to do. It actually involves some sort of smarter ways of doing things. And if you really just look at the math, if you have 10 people in a COE, they can only do so much testing. But if you have 1,000 developers and they're all learning to do even just a little bit of testing, you can get a lot more testing done. And we've seen places go from sort of 100 tests a year to 1,000 or 10,000 tests a year. That's really how you get coverage. Thanks again for your time. Don't hesitate to reach out to the team that invited you to this call if you have any follow-up questions at all. And thanks again for your time. Have a great day.